Let's go over all these. That's not today, though. Today's only going to be the parallelogram and triangle, and then Monday we'll hit up trapezoid and kite. Let's go over all the formulas now and get them out of the way here. Some you are probably familiar with. So let's start with parallelogram. Parallelogram. That's a figure we talked about. Well, I didn't talk about it, but you guys talked about it this year. Base times height. And look, that's great that if you know it. Area is base times height. But do you know what the base actually is and the height actually is? So let me talk about that on my diagram here. The height of a parallelogram. We've actually used another word all year long that you can fill me in with in a second. Height. From a vertice, perpendicular to the opposite side. We never used height, we use altitude. Darn right. So that's the height equals the altitude. And here's what I got to break now. This base equals bottom middle school mentality. That's not the case. Base does not always equal bottom. Watch. Let's say I got rid of that. And let me draw this height in instead, which is also still the height. Sometimes it might be outside. So there's my height. The height will always be drawn to your base. Okay? That's how you can always figure out where the base is located to plug into the formula. The height will always be drawn to the base. So in this case, that's what I'd be using for my base. All right, so get it out of your head. Base does not always equal bottom. Base is whatever the height is drawn to. All good. Anybody know the circle one? Circle? What's up, Kyle?
Pi radius squared.
Pi r squared. Look at you. Yes. Pi times the radius squared. Good work. Triangle? Base times height divided by 2. I like 1/2 base times height. That's how I roll. 1/2 BH. Can we just talk about a right triangle first before we move on? Because you're going to be seeing a lot of right triangles, and I'm going to ask you for the area of them. What's considered the base and the height in a right triangle? The legs. Remember that. It's not anything I draw in. The base and the height are the two legs of a right triangle, okay? I don't have to draw those in. Rectangle. Well, actually, first, everybody, let me stop here. Go to your formula sheet for me in the back. These are the only 3 formulas on there, are the ones we just went over. I know, they're really doing you a favor, huh? Putting the 3 easiest ones on there that you don't have to memorize. The remaining ones are on you now. Okay, so just make sure we're good. Parallelogram, circle, triangle are on the formula sheet. The rest of the ones we're going over now are not. Rectangle, anyone got that one? Rectangle, length times width. Yep, base times height, however you prefer it. Whatever you think is the width and the length. All right, length times width. Whew, okay, now we start getting crazy. Trapezoid? Trapezoid? 7th period kind of put it together. Anybody know anything about the trap? No, Nick?
Base 1 plus base 2 divided by 2 times the height.
Look at you, not bad. Not bad, a wizard. Okay, first thing he said was base 1 plus base 2. What's that mean? Remember in a trapezoid, you have 2 parallel sides? Those are your bases. He also mentioned height, which is the same height I've been talking about all day, the altitude, perpendicularly opposite side. So it's 1/2, and this is how I write it, the height. You take 1/2 the height and then multiply that by the bases added together. And again, the bases are the parallel sides. Questions? Rhombus kite. I'm not expecting anybody to know that. 1/2 times D1 times D2. And you don't have to have the multiplication symbols in there, but I just want to make sure we know we're multiplying. D, and it's a rhombus. Think about it. Only part of a rhombus we know starts with D. Diagonal length. D is equal to diagonal length. And remember, it's a rhombus, so they are not the same values. Today, parallelogram triangle. Monday, trapezoid rhombus. All right, so here's how we're gonna do it. What do we got here, bud? Oh yeah. Thank you. Hey, have a good weekend. Behave. All right. Here's what's gonna happen. Sure, I know the formula. BH. But do you think I'm just gonna serve up B and H and all you gotta do is plug it in, type my calculator, and here's my answer? No. I might give you B, but you're going to have to use something we talked about this year to find the height. And that's what you and your groups are going to do today and Monday is, oh, wait a second, I remember that topic. Here were the rules for that. So look at example 1, perimeter and area. Ooh, big decision coming up. Big decision. 15. Who's got 15? Perimeter or area, John?
Area.
All right, let's do area first. You got it. So area. Base times height. And I actually did serve both up here. I just want to make sure you can identify. There are 3 values on here. Which one's the base and which one's the height? Let's start with the height first. From the vertice, perpendicular to the opposite side. Which one of those 3 values would be your height? 14. 24. Times the base. The height is drawn to the base. And the base has to be part of the parallelogram. You just can't give me a number that's not part of it. So now the remaining 2 numbers, which one's the base? 5? 23. Why is 7 not a part of it? It's not part of the parallelogram. All right, nothing on the parallelogram is 7 feet. The base is 23. We put them together, 23 and 24. What do I have? 552. Now, I'm still sticking to my rule all year long. I don't care about units because on the regions we don't take off if you don't put them. But if you are putting units, I will take off if they're written incorrectly. It's just not feet. We're doing area now. You sure?
Feet squared.
Square feet, yes. Feet squared. So if you are going to put units, put the correct ones. All right, now let's go to perimeter. Now we got to do a little extra work. Perimeter, all sides added up. The only side I know is 23. You know another side then? 7. Only side I know is 23. What about another side? Okay. 7 and 24 aren't part of the parallelogram. They're not side lengths. Perimeter, all 4 sides added up. Right? Yeah, what about that side? 23. How do we know it's 23? Property of a parallelogram. Opposite sides congruent. Woo! Now, I didn't serve that side up to you. But at this point, we better know how to find that side. You want to talk to your group for like less than 5 seconds on how I can find that side? How can I find that side? And we're done. How can I find that side? 13. Pythag, yep, good work. A squared plus B squared equals C squared. Can you plug in, please? 7, you want to plug in Pythag for me. Let's go. There we go. Go ahead when you're ready. Let me know what C is equal to. Take your time. 27 when you're ready. What's C equal to? What do we have? 25, yep. All right, so there you go, kids. Plus 25. Plus 25. So the perimeter here, 50 and 46. Give me 96. And then be careful here. What would the units be if you're using them? Just feet. The only time I square them is when I do area. Woo! Questions? All right, so I could do Pythag to find a missing part. Let's use some other things from this year to find missing parts. Now we're just finding area, no perimeter. Everyone see the height? Didn't give it to you. We'll talk about it in a second, but I did give you the base. You may not see it there, but I did give you the base. The height is drawn to the base, and it's a parallelogram. Let me put those two together. The height is drawn to the base, and it's a parallelogram. What's the base length up here? 7? 17. Hey, everyone. You're like, wait a second. Here's the base, right? The height's drawn to the base. How do you know it? Oh, opposite sides are congruent, right? Opposite sides congruent. So the base is 17. Oh, you ready for this height now? Oh, now what are we going to review? 45, 45, 90 triangles. Yep. So I'll give you more than 5 seconds now. In your groups, there were 2 rules on how to find the sides of a 45, 45, 90. Let's roll. Go ahead. Talk to each other. How do I find those sides again? Dig deep. What did you know about the sides of 45, 45?
If it's a 45, if it's 45 triangle, take both sides by
Okay, here you go. What was one rule? 19, one rule. That was a mouthful, Ellie, and I don't want to write all that. Do we have a special name for those 2 sides in the right in a right triangle? There you go. Thank you. Legs are congruent. Good work. Legs are congruent. So that means the hypotenuse is left. How do I find the hypotenuse then? What was that rule? Whoa, 5. Multiply by what? Multiply what by radical 2?
Oh, the leg.
Thank you. Leg times radical 2. Good. All right, now go back to the diagram. What is the height then? Is that a leg or a hypotenuse? The height is what? 27, leg or hypotenuse? Leg. The other leg was 9. They're congruent. My height is 9. Boom. Just not memorizing a formula. Need a little more than that in this unit. 153 square yards. All good. All right, you know, we give the 45, 45 a little love. We got to give 30, 60 a little love. Whoa, before we get there, how about the base here? I know that's the height, but what about the base? 17? 32, good work. All right, the height is part of a 30, 60, 90 triangle. So go back to your group. Whoa. Let me just give you some direction. There are 3 sides to a 30, 60, 90. There's the shorter leg. There's which is across from the 30. There's a longer leg, which is across from the 60 and has a rule. And then finally, there's the hypotenuse, which has a rule. Go ahead. What were those rules? What were those rules? All right, what do you got? Longer leg rule. 10, longer leg rule. What is it? Shorter leg times radical 3. Good, Zach. And then how about hypotenuse? 19. There you go. Double it. Good work. All right. What's the height then? Shorter, longer, or hypotenuse? What's the height? That's what side of that triangle? 5? Longer leg. So you guys have to tell me I got to take the shorter leg and multiply it by radical 3. Leave the radical there. What is the hypotenuse now? How long is the hypotenuse? 17. What's the shorter leg?
12.
Times? Put them together. 12. No, just put them together. I don't need a decimal answer yet. Just 12 radical 3. That's all. Yep, that's all I was looking for. Oh, you guys are lucky. Round to the nearest 10th. How's your rounding rules? Come on. 4, rounding correctly to the nearest 10th. 600. That's hundredth. Tenth. Just one. Yep. Meters squared. Woo! Questions? All right, there's your parallelogram. Okay, there's your parallelogram. Let's go on to area of a triangle now. And there he is. Yep, he's going to be making frequent appearances in Unit 11 and 12 before his big reveal last day of classes. What's he got? A triangular. He's got a lot of land. And then he's going to have a backyard coming up here in example 4. All right, so bottom line, can you help Big Al find the area of his land, ACD? Well, it's a triangle. We're not BH anymore. We're 1/2 BH. And let's keep going with that. ACD is what type of triangle?
Right.
It's a right triangle. We already went over how to find the right triangle area. Leg times leg, right? 1/2 leg and leg. Well, I see that one leg is already given to me. That is 15. What about the other leg now? AKA, I'll just write it in here, AC. Right? How do I find leg AC? I know part of it's 16. That would be awesome if I knew AB. Then I could add it to 16. Any thoughts on how I could find AB? Because that's the missing key here. 24. Thank you. A squared plus B squared equals C squared. Make sure we're doing it on the correct triangle. Next up, give me some values to plug in there. Oh, 9. Got it. When you have B, let me know. The value of B here, 22.
It's 20.
It is 20. But again, that's not what I plug into the formula, right? AC is not 20. I'm going to plug in 36. So Big Al's plot of land, 270 square yards. Questions? Next up, let's go to his backyard and his garden. Both rectangular. Find the area of his garden. Well, we just went over rectangle is length times width. And you guys are already seeing, I already know one side is 6. And let me highlight the other side. Somebody's going to help me get here. This side right here. Since it's length times width, I need to figure out what that side length is, right? Can you help me get there using his backyard as a rectangle? How are you going to get me there? Just walk me through it. 2-1.
Pythagorean theorem.
How?
Because
Go ahead, Dan. Talk here.
the corners are right angle.
They are because it's a rectangle.
Yeah. Oh, keep going.
Yeah, I look. I got a right triangle with nothing.
Yeah, and then you do 40 minus 15.
Yep. Opposite sides are congruent, so that side's 40 minus 15. I get 25 here.
And then the other side is 10 because 80 minus 70 equals 10.
Thank you. And Dan already gave it away. We are going to use Pythag. Somebody else, plug it in for me. 9. Plug those values in.
10 squared plus 25 plus 2 squared.
Thanks. Oh, it's not a perfect square, is it? Okay, so, by the way, since we're coming closer to Regents time, is this my final answer when I find C? No, why am I asking you that? I don't want you to shorten the answer here. You got what? Square root of 270? Whatever that is, 270? Nope, how about 725? Not even close. Where did 270 come from? 725? That's not my final answer. So don't shorten it on your calculator either. Take that whole thing, and plug it back into the formula. When do we round? We round at the end of this problem. And what's the rounding directions here? Nearest square foot. So nearest foot, basically. Whole number. When you have it, let me know. Come on now. Look at your calculator. 7. What'd you have? 2, yes. Square feet. Whew. All right. Perfect. Questions with anybody? All right. Last topic here. Called population density. I don't know if they do it, and I don't think they do it in earth science anymore. Population density. Before I got a formula up there. I don't want you to use the formula until you understand actually what this concept is. I put a little note up there, number of people in an area relative to its size. So right now in this classroom, right? In this classroom, we have a certain population density. I'll take there's 28 of us, I think, in here, divided by whatever the area of this classroom is. That'll give us a number. We go outside to the field, that number goes down. Why does it go down? Same amount of people, but in a bigger area. Okay? So the more people you have packed into a smaller piece of land, the higher your population density is. Okay, so that's what population density is. How many people do you have in a certain size area? There's the formula, population over land area. So the first thing I'm going to do with you is go to the 5 boroughs of New York City. And we're going to find out here, or you're going to find out on your own here, which one has the highest and which one has the lowest population density, using our formula, which is something you're on the hook for. That's not on the formula sheet. So let's go through every borough right now, calculate its density, and then we'll talk. If anybody wants to try to keep it a little more organized than just having numbers flying around your paper, you can add a 4th column in here, which is your density column. I hate to see that. All right. So you look at your results. The borough with the highest population density, Manhattan. And the one with the lowest, Staten Island. $77,587. That's what I got for Staten Island versus the rest are like in the 10,000s. Okay, I'm glad you could find them and answer the question, but I really want you to know, hey, let's get a, what's this actually mean, right? Especially in an honors level class. This is the land areas by square mile, which means take a square, just think of it as a square. That's 1 mile by 1 mile. Okay, pretty big square, I know, but so Manhattan, you got about 67,000 people there in that square. 67,000. Versus Staten Island, you only have about what? 7,600 people there instead. All right, so see the difference between a very high population density state or place versus a low population density. I don't want to go on to the Petri dish question yet. Let's play a little game here. Do we really understand population density? Let's go to the 50 states. 50 states and predictions. Which one has the highest population density? The highest, meaning, again, what's high? If you have a high population density, you're like Manhattan, right? Decent piece of land with a lot of people packed in. And what state has the lowest? Not many people in there. Each group come to a consensus on your highest and your lowest. Each group say. No. Well, I know the answer.
I like Hawaii. I think that's a good bet. Yes, let's go. We're like small. No. Lowest? Oh, that's right. You're right.
Okay, here we go. Hopefully we had some good discussion here. Let's go. Let's go around every group. Let me know your highest and your lowest. And we'll see if anybody hits it. What do we got over here? Highest?
Highest is
New Jersey.
New Jersey. Lowest?
Alaska.
highest is New York, lowest is Alaska.
Common theme here so far. Back group?
Highest California, lowest
Yeah.
Alaska.
No.
Can't be the same as another group.
Middle group?
Oh, the highest is New York, lowest is Alaska.
Okay.
Yeah, we want highest as Hawaii and then
Montana.
lowest is
Montana's
Montana.
We said highest is Rhode Island, lowest is Alaska.
Back group?
The highest is
Okay, so it seemed like a lot of people were in agreement with the lowest one, which is Alaska, which is correct. All right, I think right above Alaska is Wyoming and a couple of the Dakotas as far as the lowest. The highest, nobody got, but you guys were all in the right area. A lot of people picked states from the Northeast and New England, and you are correct. The highest one, Delaware. And I think New Jersey is number 2. Massachusetts, New York, Rhode Island, they're all in the top at least 10. Yep, a lot of the New England ones. So good job. Prove to me you guys know how this works. All right, one final one now. This was an actual Regents question 7 years ago, I guess. So you got 2 Petri dishes. Petri dish A has 40,000 bacteria in it, and Petri dish B 72,000. Which Petri dish has the greatest population density? And if you really don't understand it, you're just going to see this word greater and pick the biggest one, which may not be the answer. All right? Remember our formula. No, that's not it. Population density equals population, which I have, 40,000 and 72,000 over land area. Unlike the boroughs question, I didn't give you the land area. What shape is the land area? Circle. I did give you that area formula at the beginning of today, and it's on your formula sheet. So the first thing you and your group are going to have to do is find the land area so you can plug it into the population density formula. And darn it, we just finished this unit. Are you going to plug 51 in to R? No. What's 51 in this problem? Diameter. Cut that sucker in half. Same with 75. All right, so go ahead. Calculate your land area. Don't round it because it's not your answer. Remember, don't round it. Then plug it into your population density and see which one actually has the greater density.
I just wrote it all. Yeah, I got.
It's right above the
There's gonna be some from what they he's gonna pick it up like that. She's also gonna like take scissors and how the kids moving.
Oh my god.
Everything but the comments is right.
I know it's my aunt makes scissors. It's almost like a
Just run the previous.
You did 30,000, you 40,000.
Those would be. I'm not sure, but I might.
I got the
Hold on. Some people take like their own options. Yeah, I see that.
Make sure our densities match. And then hopefully you've gotten in your mind now when they ask for population density, it's not really how large the figure is. It's how much is packed into that figure. All right, and it was Petri dish A that had the larger population density. All right. 2 sides to the homework, page 4 in the packet, and then the rest in the book. So wherever you want to go ahead. You got plenty of time. Let's not waste it.